Let's journey back in time. Not just a few years or even a few thousand. Our destination is 6 billion years ago. The universe was younger then, and honestly, it was a place of breathtaking activity and untamed energy. Imagine gazing into this adolescent cosmos. You would see a sky just buzzing with light and creation. This was a time when the universe was hitting its stride, a period of intense and spectacular growth. The quiet darkness we see today was punctuated by brilliant bursts of light. Galaxies were not yet settled into calm spirals. Instead, they were vibrant, chaotic, and much closer together, like a crowded city in a festival. The cosmos was a masterpiece in the making. Everywhere you looked, galaxies were being born. The universe's great construction phase. The universe hummed with formation, a symphony of gravity and light. Now, you might wonder, what was guiding all this cosmic construction? What was the blueprint for this grand design? The answer is something we cannot see, touch, or feel. It's called dark matter. It doesn't shine. It doesn't reflect light. It doesn't interact with us in any way we can directly sense. Yet it's the true architect of the cosmos. Dark matter forms a vast, invisible scaffold throughout the universe. Think of it as a cosmic spider's web. Galaxies are like dewdrops, clinging to intersections. Filaments, nodes, vast, empty voids. The densest parts, the nodes where filaments cross, are where gravity is strongest. Dark matter pulled in the first clouds of hydrogen gas. It acted as a gravitational anchor, a seed around which visible matter could gather. Dark matter was the shepherd, gathering hydrogen gas into the pens where galaxies would be born. With galaxies growing closer together on the threads of the cosmic web, encounters were inevitable. But these weren't gentle meetings. They were titanic collisions, a cosmic ballet of gravity and gas playing out over millions of years. Imagine two young galaxies, each a swirling city of billions of stars, drawn together by their mutual gravitational pull. As they approached, tidal forces would begin to stretch them, pulling out long streams of stars and gas like taffy. These tidal tails, sometimes stretching for hundreds of thousands of light years, are the beautiful scars of these gravitational battles. During these mergers, the stars themselves rarely collide. The space between stars is simply too vast. But the vast clouds of gas and dust within the galaxies are a different story. This collision creates massive shock waves that ripple through the interstellar medium. The gas is compressed to incredible densities and heated to millions of degrees. This sudden, violent compression is the trigger for an astonishing burst of star formation. The merging galaxies light up with the brilliant blue light of millions of newborn, massive stars. Small, irregular galaxies merge to form larger, more structured ones. It was through this process of hierarchical merging that the grand spiral galaxies, like our own Milky Way, began to take shape. The universe was building itself up, one collision at a time. Destruction gave way to a new, more magnificent form of creation, forging order from chaos. Within these young, active galaxies, another incredible story was unfolding: the birth of stars. Tucked away inside vast, cold, dark molecular clouds were the stellar nurseries of the cosmos. These clouds, hundreds of light years across, are reservoirs of raw material for star formation. 6 billion years ago, these nurseries were working overtime. The frequent galaxy collisions and mergers compressed these clouds, triggering collapse. Within collapsing cores, the density and temperature began to rise. A protostar began to glow in the darkness, gathering material from its cocoon. Its core grew hotter and denser. Pressure built, temperature climbed to about 15 million degrees Celsius. Nuclear fusion ignites. Hydrogen fuses into helium, releasing a tremendous amount of energy. That outward energy balances gravity. A star is born, emerging from its dusty cocoon, shining. Much material remains nearby. Gas and dust swirl in a flat, rotating disk. This protoplanetary disk seeds new worlds. Tiny, icy dust grains begin to stick together. Clumps grow into pebbles, pebbles grow into rocks, and rocks grow into larger bodies called planetesimals. Rocky planets form. Farther out, where it's colder, giant planets form. The universe was making stars, and the potential for planets. The most massive stars in these young galaxies lived fast and died young. They were the rock stars of the cosmos, burning through their fuel at a prodigious rate, shining with a brilliant blue-white light. many thousands of times brighter than our sun. But their spectacular lives were destined to end in the most spectacular way imaginable: a supernova explosion. After only a few million years, these giant stars would exhaust the hydrogen fuel in their cores. Gravity would once again take over, crushing the core and raising the temperature to even more extreme levels. This allowed the star to begin fusing heavier elements, helium into carbon, carbon into oxygen, and so on, up the periodic table. This process of stellar alchemy creates the elements that are essential for life. The carbon in our DNA, the oxygen we breathe, the calcium in our bones, the iron in our blood. All of it was forged in the heart of a massive star. When the star's core has been converted into iron, it can no longer generate energy through fusion. In a fraction of a second, the core collapses under its own immense gravity. This triggers a catastrophic rebound explosion that blows the outer layers of the star apart. For a few weeks, a single supernova can outshine its entire host galaxy, releasing more energy than our sun will in its entire 10 billion-year lifetime. The elements forged inside the star, along with even heavier ones like gold and uranium, are scattered into space. This enriched material, this stardust, spreads out into the interstellar medium, seeding the surrounding gas clouds with the raw materials for the next generation of stars and planets. Each supernova was a gift to the cosmos, making the universe a more complex and interesting place. It meant that the next generation of planetary systems would have the ingredients needed to form rocky planets, atmospheres, and eventually life. As we pull our perspective back and look at this adolescent universe, we see a cosmos at its peak. This era, around 6 billion years ago, marks the high point of star formation. Compare that fiery, adolescent universe to the one we inhabit now. Today's cosmos is quieter, more mature. Galaxies are farther apart, mergers are less common. Gas reservoirs have been depleted. Star formation rate has fallen to less than a tenth of its peak. We are lucky to be here now, able to look back and piece together this dramatic history. This story, the cosmic web, colliding galaxies, stellar nurseries, supernova explosions, is not just distant or abstract. It is our story. Iron in the core of our planet, iron in our blood, come from the heart of a long-dead star. Carbon that forms life's basis was forged in stellar furnaces and scattered by supernova blasts billions of years ago. We are literally made of stardust. The universe is not separate from us. We are a way for the universe to know itself. So the next time you look up at the night sky, remember this journey. Remember chaos and creation of the young universe. Remember the invisible web holding it all together. Remember the stars that lived and died to provide the ingredients for our world. You are connected to the most distant galaxies and the most ancient stars. You are a living testament to the universe's creative power. Atoms forged in fire scattered across the void, eventually coming together on this small blue planet to wonder at it all.